On today's episode, can heat pumps save the environment? Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. Now, long before environmentalism and climate action, engineers in the climate control industry mastered mechanical refrigeration. It's now so ubiquitous that we take it for granted, but it's actually a minor mechanical miracle. It's a basic principle of physics that the phase change of matter from solid to liquid and liquid to gas absorbs and releases a great deal of energy per unit mass or volume. Now, examples of this are almost too numerous to mention, from ice cubes in a drink to Florida orange growers watering their groves to protect against frost damage. In hot, arid climates, evaporative cooling is a low-cost way to get mild cooling, and these so-called swamp coolers have been around since ancient Egypt and Persia. But true air conditioning replaces open-loop evaporation of water with closed-loop evaporation of pressurized refrigerant compounds, with the resulting gas being compressed and passed through a heat exchanger called the condenser for reversion to the liquid state, creating the very effective closed-loop process that can create deep freeze conditions. Now, mechanical refrigeration is effective, but the energy required to operate that compressor, plus fans to move air past both evaporating and condensing heat exchangers, is considerable. Now, anyone who's felt the outside of an air conditioner knows that the heat is rejected to ambient. Run this process in reverse, and it's possible to extract heat from ambient and move it indoors. Now, this is the principle of the heat pump, essentially a reversible air conditioner. Heat pumps have been used for space heat since before World War II and are attracting attention today because of the dual drivers of CO2 reductions and energy efficiency. And these Carnot cycle devices can be very energy efficient. For refrigeration, there is no cost-effective alternate technology, but for space heat, there are many options. If the move to phase out combustion of fossil fuels continues, the choice will be between electrical resistance heating and heat pumps. Now, resistance heating is very efficient, and almost every kilowatt of input energy is translated into heat. But moving heat is more efficient than generating heat, and according to the German Federal Office of Economic Affairs, every kilowatt hour of energy consumed in a heat pump can deliver 3 to 6 kilowatt hour equivalent of heat into the building. The problem is cost. According to the International Energy Agency, heat pumps are 2 to 4 times more expensive than natural gas-fired equipment for the same output. Now, bridging this cost gap is addressed by government subsidies, taxation on fossil fuels to increase gas and oil heating costs, and in the future, legislation simply prohibiting fossil fuel-fired equipment. But can heat pumps work everywhere? As every engineer knows, heat transfer is dependent on the temperature difference between the intercooler and ambient. In the winter, heat pumps effectively refrigerate the outdoors, and the temperature difference between the device operating in evaporator mode and external temperatures in cold climates will be low, affecting system efficiency. The same is true in the other direction, with a heat pump effectively warming the outside air in hot climates. The physics suggests that heat pumps will be most efficient in temperate zones. In hot climates, more electricity will be needed to drive higher capacity systems, and in cold climates, some combination of fuel-fired electrical resistance heating and heat pumps may be needed for lowest cost in space heat. In Europe, the interruption of Russian gas supplies has created a great incentive for heat pump installation, which has been seriously hampered by the lack of skilled labor to install the systems. Heat pump technology is mature, reliable, and can replace the combustion of fossil fuels for heating applications. Making it cost-effective, however, is a challenge for manufacturing engineers and politicians. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future and Designing the Future, not found on our YouTube channel. The links are in the description below. Thanks for watching.